Hi, I'm Mike Festa, and this is a quick demo of the glTF Asset Auditor. This is a tool that we created at Kronos as part of the 3D Commerce Group to check a 3D file against a given use case profile. So the idea is that there's a lot of different, 3D commerce retailers and advertising platforms. Each of them are doing these checks internally, and we wanted to make an open standard and an open source tool to allow the content producers to run tests against various profiles. So if you're going to be publishing content to, let's say, Amazon, or using ads in Google or on Snap, there are different requirements around file size, texture size, etc. And today we're just going to take a quick look at the web demo page. I'm going to do a separate video for the node-based command line implementation, which is probably what would be used for pipelines and automated processes. But today we've got this tool that's live as part of Kronos. So here's the website. It's the glTF Asset Auditor. This is a simple, non-flashy implementation that allows you to just test out the product itself. There's a couple different steps involved. The first one is choosing your settings. You can download and save settings and then load them up. You can stick with the existing 3D Commerce recommended settings, or of course you can customize these. So I'm going to start by just clicking Edit Settings. Again, this is kind of where you start. There's a variety of checks that we perform. This also runs the glTF validator, which is worth mentioning as a separate tool that will tell you whether or not your glTF file is valid as far as the JSON data that's included and the 3D geometry. The validation process runs alongside this asset auditing process, but it is kind of a separate check. The asset auditor is a little bit more subjective and use case driven, right? So we're trying to balance, file size versus, fidelity and quality, technical accuracy. There are a number of different checks that you can, if you're looking at the screen here, you can see that, we can see how many materials there are, for example, how many individual pieces of primitives or meshes are there in the file. You can check for hard edges, so ensuring that the edges are kind of smooth and rounded, looking for the object to be centered. There are a number of settings, about 20 different ones that can be checked in here, and if you put a -1, the test will be skipped. We basically pre-filled this with some recommendations, but over the next month or two, we are hoping to get feedback from a variety of different retailers, ad platforms, solution providers, anyone that's really using, glTF 3D models, especially at scale, to share their settings with us, right? What are the, texture dimensions that you care about, or maybe you don't care about the texture dimensions? Do you want them to be powers of 2 or, quadratic square textures? Do you care? Do you want to check that the UV shells are properly separated so you don't have edge bleed? These are all things that the tool can check. And in the future, we want to add additional features to this tool. So we're also soliciting feedback around what checks are potentially missing. So again, you can edit these, you can download the file, you can re-upload a new file once you download it and saved one, or you can use the standard settings, which I'm going to do for the very first test. Step number 2, this is an optional step if you have product information. Again, we envision this being part of a asset creation pipeline or an ingestion pipeline where you're probably connected to a database that might have dimensions of every product that's coming through. So for the sake of this demo, we're going to be looking at a diffuser that has these known product dimensions. So if I just open up this file, it's pretty simple. It just says dimensions, and then it has the length, width, and height. These are in meters. I'm going to load that file in and just drag it over. It's optional, so you don't need to check the product dimensions. But for this demo, I wanted to show how it works. Lastly, we're going to load the 3D model. And I'm going to take this diffuser file. It's a big one. It's 16 megabytes. This is all loaded locally in the browser, by the way, so nothing's getting uploaded. Once it's done, the 3D model is going to show up. You can rotate that and zoom in just to confirm that it's the model you think it is. As we go into the report details, the glTF validator, as I mentioned, that's a separate tool, but we do run that as a first step just to confirm, and it passes back any of the output, including hints and info that is spit out of the glTF validator. And as we go through some of these tests, you can see I failed the file size. I mentioned this is a 16 megabyte file. It's that big if we scroll down because it has 4K textures. So we also failed the texture height and the texture width. But that's okay. Some of these tests you may care more about than others. Internally you can treat a failure as a warning. The tool essentially does pass, fail, or not tested. So a lot of these tests we kind of skipped. You can actually still see some of the numbers are reported even if the test is skipped. So there's one node, there's one mesh, there's one primitive. It does have a clean transform, which means the model is kind of centered 0, 0, 0 and rotated with Y facing forward. There are several tests like beveled edges that are a bit slow. I'll actually run that in a minute and we can kind of see the process and I'll explain why it's slow. But you don't necessarily care about some of those, so you don't have to run every test. But yeah, as we get through the list, there's just various attributes that as we were developing the tool seemed like they could be relevant or important. Your mileage may vary. And again, we want to hear from you what tests are important, what tests are missing. This particular report can be downloaded as a CSV, which is going to look pretty similar to what we had here. If we just pop that open and you basically can see all the same information that's in this web implementation demo. We can also download that report in a JSON machine readable format. You notice I've downloaded a few of these as I've been testing. It appends the date and timestamp automatically. And then if you just format that, you can see basically have all the information with pass, fail, made sure it was tested or not, values that came out. So that is the main rundown. I'm going to run this model one more time, but this time, and I'm going to refresh the page. It's always a good idea to just refresh the page, then you can reload the model. I had earlier edited the settings to basically turn everything on, and I'm going to upload that file now. So this is Asset Auditor all tests. It's green if it's recognized and loaded properly. We can include the product information if we want to, might as well. And then we'll load the model. This time I'm going to load a smaller version of the model that I used with KTX textures. So it's a texture compression format that we came up with at Kronos, and that's a separate tool we can talk about another day. Right now I'm loading this model. You notice the loading message is going to display for a minute. And while it's doing that, I'll just kind of explain what's happening. So the glTF file format naturally breaks down all the triangles into individual components. So they have separate vertices. They're disconnected. glTF is meant to be a runtime format, and it's not an editing format. So that particular optimization is good for your GPU. It's not as good when you're trying to figure out, what the angle is between some edges. So it wasn't super long, but it is a little bit slower, especially if you're dealing with large files. This particular one has about 14,000 triangles. Some of the files that have over 100,000 triangles will be slower when it's recomputing all that, geometry. So just something to consider. This, again, is pretty similar results. We've got some hard edges that we wouldn't have seen without running this check before. We get some non-manifold edges, which can happen if you've got pieces of geometry. Sometimes you don't want the inside faces, so you delete those faces and you end up with an edge loop. So again, these tests are potentially important to your company. They might not be. Let us know in the comments. Another check here that this particular one failed was the color value. So for physically based materials, the range from black is 0, white is 255. But if you need to add light, you don't necessarily want your maximum white pixels to not be able to add any light to it. So generally we recommend around 243 is your maximum brightness. And then, again, things aren't necessarily purely black. in this case, this texture was. And it's also worth noting that the name here says unnamed. The conversion process kind of stripped the file name, so there was no name to report. Whereas when I ran this model before, it mentioned the diffuse file name. So yeah, little things like that we'd love to get feedback on. This is kind of version 1 of the tool. We're planning on continuing to support it and add new features. If you scroll back up to the top, we can go to the GitHub page where there's the full project. I'm going to do a separate video for the command line interface, and I'll talk more about the code.